Can you hear me now?
Yeah.
Hello.
How are you?
Oh, wait. I
Oh,
have to check my audio settings.
okay. No, it's fine. It's fine now. Okay.
What?
I can hear you very well now.
I
Okay.
can't hear you. I'm using another device. I'm using the TV to log in.
Okay.
Wait, wait.
Okay, no problem. So let me
Oh,
know. Yeah.
oh. Mama, pakilabas matinong mo para mag-adjust yung volume.
So let me know once that is done. Okay. Okay.
Ano ko lang sabihin? Saan? Saan? Ayun, dito pala.
Yes, ma.
Welcome.
Well done, ma. Okay. So, Miggy, can you hear me now?
Yes.
Okay. So can we get started now? Shall we start now?
Okay, that's why I can't hear you. My speaker was on the original speakers and not on the junior TV.
Okay. But is it working now?
Yes, I can hear you.
Good, 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 good. So you're probably familiar. We want to look at scatter plots, okay? Okay. Scatter plots. What's the topic, Miggy? Very good. Scatter. You're probably familiar with different types of graphs. You know, we've been plotting some graphs before, right? And that is
Yeah.
like line graph. Then you should have been used to bar graph and circle graph like pie chart, you know, bar chart and pie chart. You're also familiar with plotting points on the coordinate plane. So in this lesson, you will learn how to construct and interpret another kind of graph uh, with plotted points called a scatter plot. Okay. Association. This is a relationship between variables, which are positive and negative. Clustering, the grouping of data, data points around a value, clustering. Outliner, it's a data point that does not fit in general numerical pattern in the data. Then scatter plot. This is a graph that shows the relationship between two sets of data. So please, you need to take note of these 4 points, okay? Is that clear? Can you hear me?
Yes.
Good. So you need to take note of this, of these 4 points. So an association, we have said an association is a relationship between variables. For example, you may want to know what kind of association there is between the amount of time you spend studying for a test and the grades you get for the test. Clustering. Clustering is a group of data points around a value. In this data set, some of the data is clustered around 88. Yeah, some of the data is clustered around 88. If you look at this, we have 88, 88, and 88. And some are closer to it, like 87 and 89. Yeah, yeah. Okay, okay, okay. So do quick with that. Let's see.
Okay, you can go back now.
Okay.
You can go back now.
Okay, you're ready now. All right. Now, so you can see the number 88, 88, 88. So some clusters are around it like 87 and 89. Outliners. Outliners are data points that do not fit in general numerical patterns in the data. For this data, most of the students passed the test. There is one grade that does not fit in the pattern, which is 43. It's an outliner because all of the scores range from 75 to 99. but there is an outline of 43. Maybe the student was sick or in the hospital and could not do any test. That's why the score is 43, which is in red, okay?
Okay.
A scatter plot is a graph that shows the relationship between two sets of data. It usually has several points in some sort of pattern, like this. You can see all of these points, X and Y value, Y vertical, X horizontal, and these are the plots. Let's go to the next session and see. Okay, graphing scatter plot. A scatter plot has points that show a relationship or association between two sets of data. So remember, we must have two sets of data, okay?
Okay.
Yeah, between two sets of data. So the following tables show a number of goals, Amir attempted per score game and how many of those he made. So if he attempt 9, he scored 2. If he attempt 7, he scored 4. So when he attempted 8, he scored 1 time. Then, all of this data has been recorded. So let's just try to play this audio. Let me share my sound so that we'll play the audio, we'll listen to it. I want you to please focus on this.
Plotting points on a scatter plot is just as easy as plotting points on any coordinate graph. The only difference is that there are usually more points to graph. Each point in the table is graphed. Remember, when graphing points, the first coordinate tells us to move left or right, and the second coordinate tells us to move up or down. To plot the point 9, 2, first move right along the x-axis to 9. Then move up along the y-axis to 2. Then add a point. Do this with each of the points from the table, and we now have a scatter plot.
Just try to listen
To
again.
move up or down. To plot the point 9, 2, first move right along the x-axis to 9.
That's 9. Are you following this?
Then move up along the y-axis to 2. Then add a point. Do this with each of the points from the table, and we now have a scatter plot.
Okay, so this is clear, right? Is this clear to you?
Yes.
Okay, good. So let's now, each point on the scatter plot shows one observation from the data set or table. Any given point on the scatter plot shows how many goals Amir attempted and how many goals made. So if you look at the scatter plot, this is it here. Now, that's it on that one. So this is another one that says income in the thousands versus years of experience. So when you have 5 years of experience, you earn 30,000. Then 10 years of experience, maybe 31,000. 15 years of experience, 10 years of experience, 35,000. 15 years of experience, maybe like 46,000, and so on. 35 years of experience, maybe like 55,000. Okay?
Okay.
Okay, so this is the relationship then. So this scatter plot shows the correlation between years of experience on x-axis and the income on y-axis. So always your input is on the x-axis and your output is on the y-axis. So example, after 5 years of experience, what is the income? To make over 50,000, how many years do you need to work? So after 5 years, to find the income after 5 years, find 5 on the x-axis and move up. Then the income level is about 30,000 on the graph, okay? Is that clear? Now, to make over 50,000, how many years do you need to work? To find out how to make over 50,000, find 50,000 on the axis, then move to the right until you find the data plot points, then it looks like you won't make more than 50,000 until you work about 27 years. So 50,000 here, 27 years down here, beyond 25. So let's go to the next session. Okay, here is another video to watch on interpreting scatter plot, okay? I want you to listen.
An association is a relationship between variables. Scatter plots can have a positive association, a negative association, or no association. Scatter plots
Take note, scatter plots can have a positive association or a negative association or no association. Let's continue.
can have a positive association, meaning the graph goes up as you move to the right. This makes sense because the more years of
So positive association means it goes up as you travel to the right on the plane, okay?
experience you have, the more income you make. Scatter plots can have a negative association, meaning the graph goes down as you move to the right.
So look at the negative, the graph goes down as you move to the right.
Scatter plots can also not have an association, meaning
And just look at this. There is no particular pattern. You move to the right, it still comes down, or it can go up, okay?
there's no pattern to the data. Let's look at a few more examples to decide what the association is. This scatter plot has a positive association because the data tends to go up. You can draw a line to help you see the association.
Look.
And this scatter plot has a negative association. Remember, you can always draw a line to help you tell if the data is going up or going down, or having a positive or negative association.
Teacher Jibola.
Yeah, can you hear me now?
Yes.
Okay, that was network interruption there, okay?
Okay.
Yeah, so let's continue. So you can see where the outliners are. An outliner is a data point that does not fit in the general pattern of the data. On this scatter plot, there are two data points that are much higher than others. So they would be considered outliner. So outliner can be bigger than the rest or smaller than the rest. Is that clear?
Yes.
So, hold on. All right, so now, lastly, a scatter plot makes it easy to see where there is clustering or grouping of data points around one value. Okay, let's look at this. We have a kind of clustering here around other values. So let's go to the next section. Okay, before we go on, make sure you are able to construct scatter plots and interpret scatter plots. So let's work on questions, okay? Okay, can you hear me? Yeah. So now let's try to match this. A graph that shows the relationship between two sets of data is called what? Yes, what's your answer, Miggy? The first one, a graph that shows the relationship between, that's the scatter plot, okay? That's number one. A data point that does not fit into the pattern is an outliner, okay? That's number two. The grouping of data points around a value is called clustering, and that's number three. So then a relationship between variable, which can be positive or negative relation, is association, okay? Is that clear?
Yes.
Okay. So let's go to the next question. In order to make 35,000, about how many years of experience do you need? 35,000. That is about 10 years. Can you see it on the graph?
Yes.
Okay. So 10 plus 35 goes to the right, then downward 10. Then the next question there. When graphing a point on a scatter plot, first move dash and then move dash. When graphing a point, first move right and then move up, okay?
Okay.
Yeah, so. Then the next question. Use the scatter plot to find the missing number of i's in the table. So 155 pounds. Let's go to the pounds. 155. This is 150. 155 is around 67. Okay.
Okay.
Then 72. I 72. So it goes to 220 at the top here. Can you see it at the top?
Yes.
So 220 pounds. Then at 77, it goes to 240, okay, at the top. Is that clear?
Okay.
Then 195 pounds is around this place, so it goes down to 74. 74. Then 68, at 68 inches, we have 175, okay?
Okay.
So you need to take note of this because there will be tests later. Then what is clustering? Yeah, data points very randomly, many data points clustered to one particular value, close to one particular, that is clustering, okay?
Okay.
Describe the association for this scatter plot. As you move to the right, it goes up. That is positive, okay?
Okay.
Then which statement indicates a positive association? As one variable increases, the other variable stays the same? No. One increases, the other increases. They both increase, okay? Then, according to this scatter plot, about what age do people earn 17? Who can spend 17 eating out? $17 eating out. So $17 is around here. That is at 17, okay?
Yes.
So those $17 up here, and you trace it down to 17. Then the next question, let's see. This scatter plot, as you move to the right, it stays the same at a spot, then it goes up, comes down, goes up again, and comes down again, okay? So we can say,
Okay.
yeah. Okay, you say, how is the point 2,9 in the scatter plot described? 0.2,9. So 2, 9 is an outliner, okay?
Okay.
It's an outliner because it's way higher than the rest. So outliner. Then the next one. Complete the following statement. The point dash dash is circled. So the point 3, 4, okay? 3, 4 is circled. So the next one. Can you hear me now?
Yes.
So as you move to the right on this one, it goes down. So that's a negative association, okay? And let's submit this before we see. So what is the score for this?
100.
Yeah, so make sure you concentrate on the next level, okay?
Okay.
Now, numerical patterns in a table or graph. Let us see. Math has plenty of rules. In this lesson, you will find rules of creating and reading tables and graphs using the additive and multiplicative relationship, right? So additive relationship in an equation where a variable y results from a number being added to another variable x, that is additive. Multiplicative in an equation where a variable y results from another variable x being multiplied by a number. So additive relationship is an equation that is, being added or subtracted from another number. So that's additive. Like 1 plus 2 gives 3, x plus 1 gives y. X plus 2 gives y, okay? Is that clear? So whatever x is, just add 2, you get your y. That is additive. Multiplicative. Whatever x is, just multiply by 2. So it could be 2, it could be any number you are multiplying with, and it could be 2, it could be any number you are adding or subtracting in additive or multiplicative, as the case may be. So let's go to the next section. Additive relationship in a table of graph. Using a model in a good way to demonstrate what additive relationship is. So in order to compare these two models using an additive relationship, you can compare the sizes, and see how many more red blocks are needed to for the red side to be as long as the blue side. So if this is 1, then we need 3 more. So that means whatever the red is, add 3 more to get the other one. Okay. So the blue block is 3 units longer than red block. So, and the red block is 3 units shorter than the blue block. So you can use an additive relationship when you're adding or subtracting the same amount, okay?
Okay.
Determine the missing y value and write an equation for the table. So 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8, and 5 plus 4 should be 9. So the missing value here should be 9. And the equation should be x plus 4. Whatever x is, just add 4, okay? Look at the table and try to determine the equation. Okay. 7 plus what gives me 16? 7 plus 9. 9 plus 9 gives me 18. 11 plus 9 gives me 20. 13 plus 9 gives me 22. So 15 plus 9 is what, Miggy? 15 plus 9 is what? Miggy? 15 plus 9. That should be what? 24. So x is 20. So y is 24. That means x plus 9 is the equation. Okay?
Okay.
Aria has decided that she wants to start working every day. She collects data for 5 days. If her pattern continues, how many minutes will she work on day 8? So day 1, 11 minutes. Day 2, 12 minutes. Day 3, 13 minutes. Day 4, 14 minutes. Day 5, 15 minutes. So day 8 should be 18 minutes, right?
Yes.
Good. So what's the equation for this? That is the day plus 10, okay? This x plus 10 is y. Use this graph to write an equation. Okay. When x is 8, y is 0. When x is 12, y is 4. When x is 16, y is 8. When x is 20, y is 12. So whatever x is, take away 8, then you get your y. So when x is 24, take away 8, you get 16, okay?
Okay.
Notice that the y values are always less than the value of x on this particular one. So with that, we have minus 8. Then multiplicative inverse. Let's use the same model as above to demonstrate a multiplicative relationship. In order to compare these two models using a multiplicative relationship, you can compare their sizes and see how many times as long as the blue block is the red block. So 4 times. blue block is 4 times longer than, as long as the red block. So that means it is 1/4 of the size. So when X is, when the red is 4, 1/4 is 1. When the red is 8, 1/4 is 2. That means we are dividing. So if this blue value happens to come first, then you multiply by 4 to get the other one. Is that clear?
Yes.
You can also grab this relationship. At 1 is 4, at 2 is 8, at 3 is 12, at 4. So, but the other way around, at 4 gives 1, at 8 gives 2, at 12 gives 3, at 16 gives 4. So that means y equals to 1/4 of x. Okay?
Yes.
So let us try to listen to this.
Let's take a look at a multiplicative relationship in a table. Moesha went to the fair with a group totaling 8 people. How much will it cost for all 8 people to enter the fair? Let's use this chart to help her decide how much it will cost. First, remember, this is a multiplicative relationship. We can tell this is multiplicative because the same number is not being added to each x value. 1 plus 7 is 8. 2 plus 14 is 16. Instead, multiply each x value by 8 in order to get the y value. In order to find the cost of 8 people entering the fair, multiply 8 by 8, which is 64. It will cost $64 for 8 people.
Is that clear?
If you were to graph these points on a coordinate plane, you will see that the points make a straight line.
Is that clear to you? Is that clear now? Okay, good. So, I want you to read what is under here. Okay? Now read it. Start from here and stop at this place. Let me hear you. Yes, can you see it better? Miguel, I'm waiting. Yeah, read what's on the board, okay? I mean on the screen. Miggy, can you hear me?
Once the relationship is uniform. Yes.
Okay. So you can continue.
Once the relationship is identified, the equation can be written. Let's use the same example to write an equation. Since every x value is being multiplied by 8, the equation is y equals 8 times. We can use the equation to find or people or 15 people by 16 the number of people in the equation for x and multiply it by 8.
Okay. Okay, so for 9 people, that'll be 8 times 9. For 12 people, that'll be 8 times 12, right?
Yeah.
And for 15 people, that'll be what? For 15 people, that'll be what?
Huh?
Yeah, for 15 people, that'll be what? 8 times 15, right?
Yeah.
That is what I'm trying to. So I just want you to concentrate on that, okay?
Wait.
Okay, example. Use this table to describe the relationship between the hours Dennis was in the car and how many miles she drove. Then write an equation. 1 hour 50 miles. 2 hours, 100 miles. 3 hours, 150 miles. So that is times 50, okay? So y equal to 50x. Use this graph to write an equation. At 2, we have 6, that is times 3. At 4, we have 12, that is times 3. At 6, we have 18, that is times 3. At 8, we have 24. And at 10, we have 30. So that is y equal to 3x. Okay, let's go to this session. So before going on, make sure you're able to do what? Read this. Yeah, read this.
Make sure you are able to use the additive relationship with the table or graph. Use the multiplicative relationship with the table or graph.
Okay, good. So I think we have to work on some questions now, okay? So let's go to the questions. For the first question. Yeah, in an equation where a variable y results from another one being added, that is additive, okay? And the other one is multiplicative. Then the next one, which equation matches this table? X minus 4, okay? The top values minus 4 each gives us the bottom value. So x minus 4. When is the additive relationship used? Select all that applies. When subtracting the same amount to an x value, when adding the same amount to an x value, when multiplying, when adding the same amount to an x value. Okay, wait. Dividing, multiplying, okay. Subtracting and adding is additive relationship. Is that clear? Which equation matches this table? X is 0, y is 6, so that is x plus 6. First values plus 6 gives us the second set of values. So x plus 6. Is that clear? When is multiplicative used? Let other applies. When multiplying the same value and when dividing the same value. We use multiplicative, okay?
Okay.
Then can you guess the equation of this table? Look at the set of values and tell me the equation. If you have 1, you multiply by 6, you get 6. If you have 2, you multiply by 6, what do you get? Look up, 12. If you have 3, you multiply by 6, what do you get? Look at 18.
18.
If you have 7, you multiply by 6, what do you get?
48.
42. And if you have 8, you multiply by 6, you get 48. So that is y equals to x times 6. That is 6x. Y equal to x is for, okay, wait, let's see. Whatever x is, half of it is y. So y is x divided by 2. Is that clear?
Yes.
Okay, good. So write the equation for this table. Now tell me the equation for the table, okay? Yeah, tell me the equation for this table. Okay. Yeah.
The equation is y equals x. Y equals x.
Y equals to what?
The fourth option.
No, it's the first one.
First option.
First option. If you had 9, you get this. If you had 9, you get this, right? If you add 9, you get this. If you add 9, you get this. And if you add 9, you get... So y equals to x plus 9, right? Right? Can you hear me?
Yeah.
Okay. Write an
Yes.
equation that match this when x is 4, y is half of it. When x is 6, y is half of it. When x is 8, y is half of it. And when x is 10, y is half of it. So y equals to x divided by 2. Okay?
Okay.
The table represents dash relationship. Is it additive or multiplicative? Check it out.
Multiplicative.
Multiplicative, that's correct, because you're going to divide it by 5. Divide each one by 5 to get the next y values. So do you want to submit the answer?
Submit the answer now.
Okay. So after now, we look at our piano class, okay? What's the score for this?
100.
Yeah.
100%.
Yeah,
But
that's
I
good.
can't play the piano. I'm here at the living room.
Okay. So you can't play the piano. Maybe today, okay? I mean, maybe tomorrow, right?
I can't play the piano. I'm
Yeah. Maybe
You
when
can
we
go
meet.
there. You can go there. The piano is at the room. If I go there, if I go far away here, you will not be able to hear it.
No problem. Let it be tomorrow then, okay?
Okay, maybe tomorrow.
Yeah, let's quickly go through this one then. So please concentrate, okay?
Okay.
Integers. The height or elevation of landforms is measured compared to its distance above or below sea level. Can you see this? Can you see this?
The height or elevation of landforms.
Yeah.
Yes,
Very good. So it's usually measured above the sea level.
Excuse me.
Okay, okay.
Okay.
All right, all right. So the eel has an elevation of, hold on, please. Okay.
Okay.
Now, the eel has an elevation of 100 feet because it is 100 feet above the sea level, okay?
Okay.
Then the valley is 100 feet below the sea level, so its elevation can't be 100 feet, though, because it is not the same height as the hill. Let's take that again. The valley is 100 feet below the sea level. Its elevation can't be 100 feet, though, because it's not the same height as the hill. Let's continue. How can we tell the difference between above sea level and below sea level measurement? In this lesson, you will learn about a new set of numbers that will answer this question, okay? Is that, yeah, so, and what we need to know, please read what is on this page. Read all of this.
Integer. A number belonging to the set made up of the whole numbers and their opposites. Natural
Okay.
number. A
Okay,
number belonging to the set made up of the counting numbers 1, 2,
Okay.
3, and so on.
okay,
Negative number. A number less than 0.
okay,
A line that graphically represents all
Okay.
opposite numbers. Two numbers that are the same distance from zero on the number, but in opposite directions. Positive number. Number from zero.
Yeah, good, good. So let's continue the next session. To name the elevation of the valley, we will use a new set of numbers called negative numbers, okay? Negative numbers are the opposite of positive numbers. So to indicate a negative number, we'll place a minus in front of the number. So the negative of 100 is minus 100, okay? So if you remember, the hill and the valley are both 100 feet from the sea level, but in opposite direction. So the two quantities are called opposite numbers. The hill has an elevation of 100 feet and the valley has an elevation of minus 100 feet. So we can tell elevations apart because the negative numbers has a minus sign in front of it, okay? So far, Mark, the numbers, the numbers you have been using are called natural numbers, which are the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. These are also positive numbers. Natural numbers are positive numbers. The set of all positive numbers and their opposite numbers are called integers. So when you have positive and negative numbers combined together, all of them are called integer, even plus 0, okay? So integers are used in many situations in everyday life. We've already looked at the example of elevation above the sea level, while elevation below the sea level is negative. Here are a few other examples. We can talk about temperature related to 0 degrees. Can say it could be 85 degree, 85 degree, and that's above 0 on a hot day, and minus 8 degree, that's 8 degree below 0 on a very cold day. Money can be represented with integers. When you deposit money in bank, it is recorded as a positive number. When you withdraw money, it is recorded as a negative number. Football measures progress forward down the field in positive yards. If there is a penalty, it is measured in negative yards. And the ball is moved backward. Years are counted by alpha, they are from 0. When the Anno Domini era AD or the Common Era CE begins. Years after AD or CE are positive. Years before 0 or before Christ era BC, before the Common Era BCE are negative. Let's look at examples. Name the integer that goes with each situation. Julius Caesar was born in 100 BC. A withdrawal of $50 is made from a bank account. A bird flies 50 feet above the surface of the ocean. A football player runs 15 yards. So the first case is minus 100 because it is BC, okay? Okay, which is the years before Christ. Yeah. Then negative 50 is used for $50 taken from account, and 500 is the distance above the sea level where the bird flew. Then 15 is the the forward movement of the player on the field. So take note of that. Let us listen to this, okay? One is to please listen carefully.
Here is a typical number line that you are used to seeing. To make it an integer number line, the opposite of each positive number is added. Positive numbers are to the right of 0, and negative numbers are to the left of 0. Each positive number is the same distance from 0 as its opposite negative number.
So take note of that. Take note of that. So we continue from there. On the list, we are on the number line. The number 4 and minus 4 are 4 units from 0, so they are opposite numbers. The number 4 is 4 units from 0, more than 0, and is located 4 to the right of 0. The number negative 4 is 4 units less than 0 and is located 4 to the left of 0. So let's see if we can locate some numbers on the number line, integer number line. Where are the following points located? -5, -3, 0, 4, and 9. So -5 is on B, -3 is on C, 0 is on D, and 4 is on F, while 9 is on H. So take note of this one. Determine which integer is larger for each pair of numbers. -5 and -7, -2 and 3, 4 and 8. Please begin, listen to this. -5 is larger than -7. -2 is smaller than 3, so 3 is larger. And 8 is larger than 4. So for each pair, we will look at their location on the number line. -5 is greater than -7 because it is to the right of -7 on the number line. 3 is greater than -2 because it is to the right. Okay, so the numbers to the right are greater. Is that clear?
Yes.
So 8 is greater than 4 because 8 is to the right of 4. So list the following integers in order from least to the greatest. The least is -8 because it's always to the left, then -4 followed, then 3, then 5, and 6. So next session. Use the sorter to practice ordering integers. So let's see it. Least to greatest. The least is -8, followed by -7, followed by -3, followed by 2, followed by 8 and 9. Okay?
Okay.
So the smallest -8, -7, -3, 2, 8, and 9. Then the other side, greatest to the least. The greatest is 6, followed by 3, followed by 0, then followed by -2 and -6 and -9. -9 is the least, okay?
Okay.
Yeah, so this is correct. Okay, let's try to work on some questions, then we round up for today. Yeah, positive
Okay.
number. Yeah, positive number. Two numbers that are the same distance. They're called opposite numbers, okay?
Okay.
A number belonging to the set made all numbers and their opposites. That's integer. A number line, a line that graphically represents all numbers. It's a number line. Number 6. Then a number that is less than 0 is a negative number. Number 3. A number belonging to a set made up of counting numbers, and so on, is natural number. A number that is greater than 0 is a positive number. That's 1. So let's go to the next question. Which situation would not be represented by -10? O is temperature of 10 degrees. All of the rest are -10. Is that clear?
Yes.
Which temperature is the warmest? The warmest is not 0, it's not all of this, it's 14. Okay. It's not a
Okay.
negative. The negative are cold. So which of the following is part of the set of integers? Set of integers, negative. Which of the following is part of set of integers? We have negative numbers, we have 0, and we have positive numbers. Okay. So both 0 and negative and positive numbers are integers. Which of the following is not the same as +3? 3 units to the left of 0 on a number line. No, that's -3. So which of the following is not the same as +3? 3 units to the left of 0 is not +3. The opposite of -3 is +3, okay?
Okay.
Which comparison is correct? 7 less than 3? No. -2 is greater than -7. That's correct. Okay?
Okay.
And which group of numbers is listed from the least to the greatest, smallest to the biggest? -7, -4, -2, 1, and 5. So this is the correct one, from the smallest to the biggest. Then, which numbers are 3 units from 0 on the number line? Which numbers are 3 units from 0 on the number line? Okay. This is 3 units from 0. This is also 3 units from 0. Okay. Is that clear? Which of the following is not an integer? Fraction. Okay. Then, what integer does the arrow indicate? To the left of 0, how many steps? 1, 2, 3, 4, 5, 6, 7. That's -7, okay? Is that clear?
Yes.
So let's turn it in and we continue tomorrow by principle. So, okay, something went wrong somewhere here. Maybe there was an option we needed to select. But that is what I'll be writing up for today, okay? All right?
Okay.